Hello, I'm Sharlenne Zamora, and today I'm going to talk about CT, the physics, windowing artifacts, the importance of the laboratory work as bond, creatine, and HCG, and GFC.
Patient dose in CT is higher than regular X-ray, and the effective dose depends on the patient tissues and the age of the person, because as younger the patient is more sensitive to radiation.
Occupational dose exposure recommendation limits is something that the technology is required to keep an eye on because the CT procedures develop higher rates of radiation. The eyewear protection is essential during these procedures because exist thresholds then detectable for opacity of the lenses is 500 to 2000 millisieverts, and for visual impairment is 5000 millisieverts. Radiation protection in general is recommended. Practice the three principles of ALARA of time, shielding, and distance. Reduce patient dose by collimate, use the proper technique, right position, and stay safe, and make sure that your patient is safe.
Artifacts. Physics-based artifacts are the result from physical processes involvement in acquisition of the CT data. Are caused due to patient movement or presence of metallic materials in the patient. Scanner-based artifacts are due to imperfections in the scanner functions. Our elliptical and multi-sectional technique artifacts are produced by the image reconstruction process. Artifacts design features incorporate into a modern CT. Scanners that minimize some type of artifacts. Some are partially corrected by the scanner software. But the main important factor that avoids CT artifacts is the proper use of technique and the proper position. Exist different types of physics-based artifacts. I'm going to focus on beam hardening, partial volume, and undersampling. Hardening is a feature where the X-ray spectrum shifts to a higher effective energy due to the removal of lower energy X-ray photons. As you can see, the shape of the spectrum shifts are the peak of this particular curve towards the right side as the X-ray passes through 20 centimeters of water or 30 centimeters of water, assuming that the 20 centimeters of soft tissue in the patient size are proportional to the patient size, which automatically harden the beam. That means that the principle of the soft X-ray produced by the X-ray penetrating the patient will get observed on the skin surface and do not contribute to image formation. Instead, contribute to a higher skin dose. Beam hardening is required to remove soft X-ray and hardening beam so that it's sufficient energy to penetrate the patient. Undersampling on CT image is one of the factors in image quality. The interval between projections can result in misrepresentation by the computer. The information that is sent to the computer, the signal is not strong enough, so they copy the real object incomplete or not as sharp as should be. The edges and small objects are not visualized. The straight and dark bands are heterogeneous cross-section bands that can appear between two dense objects in an image. I can show you here this image of the chest where the contrast is in the anatomy of both densities and can be mistaken as disease, but it's just a contrast, it's just a visual that is not pathology. Blood urea nitrogen evaluate the health of your kidneys. What is being tested is the urea, that is a waste product in the liver when the protein is metabolized into amino acids and produce ammonia. This process, which is converted into a less toxic waste product urea. This test measures the blood urea nitrogen bond levels in the blood. The nitrogen is a component of both ammonia and urea. What does the test result mean? Well, the bond tests are interpreted along with keratin results and other tests that may be performed, such as a renal panel. Bone and keratin levels, they are within the ranges of 7 to 20 milligrams per deciliter. If the range is above, that means that the kidneys are not working properly. As an example, they could be due to kidney stones or kidney failure or kidney disease. Increase the protein or breakdowns in the diet. But if the levels are below, it's because maybe a severe liver disease or malnutrition. If one kidney is functionally, only one of them is functioning properly, the levels, they may show normal. But the importance of knowing this is when we have a patient with an exam that has to get contrast, they has to be checked the levels of the bone just in case, because that's the way the body release and exit to the substance. And if the person is not able to take out of the body the contrast, it could be poison for the patient. Blood urea. HCG is a pregnancy test, and this exam is performed to affirm the pregnancy of the female patient. It's very important to know that if the pregnancy is suspected, it must be performed by the 10 days after the missing menstrual period to avoid any dangerous treatments for the fetus. The urine test of the HCG may provide false results. In some cases, could be a negative false result if the urine is diluted too much, and some use of medication as antihistaminics and diuretics may give a false positive result as well.
The glomerular filtration rate measures the functions of your kidney by the levels of the creatinine, and it's important this exam to check that the glomeruli are filtering the kidneys properly and the waste of the products are being removed from the blood, because if a patient has a exam with contrast, the contrast could be poison for the patient.
CT image reconstruction reconstruction provides a diagnostic images which increase efficiency and decrease radiation dose, offer a unique way of visualization of the anatomy, and is easy to detect specific pathologies. The accuracy of the quality of the images provide a higher contrast and spatial resolution in short time and can process raw data at lower radiation doses.
In this image, you can visualize how it looks at chest image reconstruction on CT. This patient has coronavirus, and the CT allowed the doctors to visualize how is the condition and how about the lungs are. In Canada, they are using CT scan as one of the tools to diagnose this condition. In physics, densities of different tissues on CT are measured in Hounsfield units. We can visualize here the scale of grays accordingly to the tissue. -1,000 is the air, and they go all the way to +1,000. Water will be 0. So accordingly with the type of tissue is the number on Hounsfield units that represent. Window width and center level on Hounsfield units are used to see specific pathologies or specific densities of tissues. We visualize on the first image that is labeled as A. They have an axial projection of the head with 1.5 Hounsfield units. And then on the number in the second one, that is B, they have the same projection, but it's a low density with the left frontal bone. In this one, they change the window width to enhance the color of the bone and be able to see if there's any pathology on the bone. Then on C, this image is a tomography axial of the skull, and is the perfect example of what I was telling you earlier of the ranges of the Hounsfield units, because optimize the information depending on tissues to be able to diagnose a specific pathology. Like in this case, we see an hemorrhage on the brain, and they are looking for cerebrospinal fluids. This is an anatomy image label of the chest. This image, it was for visualize the lungs and mediastinum on the axial plane, but I'm going to change to see another examples or windowing. This is an image on your left side of the thorax with window width selected and labeled, and is demonstrating the lungs. You can see visualize the lung markings and how the outer part, that is the area of the abdomen, is looking white. So they are moving the window width to change the density of the color to enhance the lung markings. This is the same patient with the image with selection of the window width and level to enhance the mediastinum. And you can compare how in your left side you can see the lung markings, and your right side just they are no longer the lung markings there, but the bone looks brighter, like whiter. This is another image of the CT axial projection of the thorax with the anatomy labeled, and it's self-explanatory.